we will go over the solutions for the final exam practice questions in this video. The first question is asking you to find the integral of v squared minus e to the power of 3v dv. Okay, so because we are using the variable v, so you have to take the dv instead of dx. It's just a changing of the notations, the letters. Okay, so we know that we can apply the power rule here and the exponential rule for the second terms, right? So it's simple. Using the power rule, I know that I add 1 to the exponents, and then I divide the whole thing by that. For the e to the 3v, I have to use the exponential rule and recall that the exponential rule, e to the kt is equal to e to the kt divided by the k and rc. So we know that we keep e to the 3v. K in this case is 3. K in this case is the number 3. So divide by 3. And then make sure you add c at the end. And the power rule, again, the integral of x to the n dx, you add 1 to the exponents and then divide by the same exponents of value. So that is number 1. The next questions, we are given the marginal profits in dollars for the cheese at this store given by P prime. Okay, so marginal is the derivative, which is P prime. So this is given. X is the amount of the cheese sold in hundreds of pounds. The profit is minus $40 when no cheese is sold. They ask you to find the profit equation function. Okay, so we are given P prime to be x multiplied by 50x squared plus 30. First, we can make the distribution of the x inside here. Right, x and x squared give me x3, and then x and x give me x squared. And to find the profit is P of x. We are given P prime. So to take away the prime, to take away the derivative, all you do now is you take the integral. The integral is the anti-derivative. It's undo what the derivative does to the function. So take the integral of P prime will get you back P. That's how the integral works. And basically all you do now, you just take the integration. P prime, we just found it here. We just simplify it here. And then this is just a power rule. Add 1 to 3, become 4, divide by 4. Add 1 to 2, become 3, divide by 3. Keep the 30 and 50 in the front. Make sure I add c at the end. And I can also simplify it. Divide 50 and 4 both by 2 to get 25 and 2. 30 divided by 3 give me 10. Now we need to find the value of c so that we can complete the function. So how do I find that? I go back to the problem and I take this information right here. The profit, that is the p value, is equal to minus 40 when no cheese is sold. Okay, so we know the profit is equal minus 40 when no cheese is sold. That means when x equals 0. So when x equals 0, the p equal minus 40. That is the initial value. So when x is equal to 0, you plug in all the 0 to the x, right? 0x4, 0x3, and then plus c, the whole thing is equal to minus 40 because that is the profit, minus 40. And you can see 0, 0, they cancel out. Let's give you the value of c, which is minus 40. Now you got the value of c, plug back in here, and then complete the function. Okay, part B, they ask you to find the profit from selling 200 pounds of the cheese. Okay, we know that X is the amount of cheese in hundreds of pounds. So 200 of pounds mean X equal to 2. Okay, because X is the hundreds of pounds. Now, they ask you to find the profits. We got the profit function here. So all you do now is you plug in X to be 2. And then make the calculation to be $240. So $240 is the profit of 200 pounds of the cheese. Okay, next question is use the substitution to find the indefinite integral. Okay, so we got this integral here. We know that we have to use the u substitution, right? And normally if you are given a fraction, we let the expression at the bottom to be u. So let u to be 2y3 plus 3y squared plus 1. And then find the u. Take the derivative on both sides. Bring 3 down here, subtract 1. Bring 2 to 3, 6, subtract 1, and then dy. We have to solve for dy, right? So dy, I divide both sides by y squared x, 6y squared plus 6x to solve for dy. And then I see that I can also pull out the x here. So we have y squared plus y. Okay. Now, after I finish the u, du, and solve for dy, I'm ready to plug back in the original integral. Okay. So y squared plus y, so right here. The bottom, we let that be u to the 2/3. Okay, 2/3 is outside. Dy, we solve it here. So I take the whole thing right here. I bring it here. This is dy. And you can clearly see we can cancel this term. So at the end, we just have the integral of 1/6 u to the 2/3 du. Much simple, right? Okay, to take this integral, extremely easy. First, I move the 6 outside, and then I bring up here, put a minus, and then apply the power rule. So add 1, and then divide the whole thing, and that becomes 1/3. 1/3, when you divide by 1/3, you are flipping that to get 3/1 with the 1/6 in the front, and then don't forget to add c. And then you can cancel 3 and 6 to be 1/2. And remember, at the end, you must plug back u to be this expression in terms of y's before, right? To the power of 1/3 plus c. Because you let u to be that. So make sure at the end, you have to get back the u to be that expression. And that's c. So that is the end of this question 3. In this question, we are asked to find the definite integral. Definite integral means we do have a limit, the lower 4 to 9. Before you can take the integral, we know that the square root means the power of 1/2. And then the same thing here. I keep the 3r and then r to the power of 1/2. And we can simplify this by adding the exponents. This is r, the same base. You add the 1/2 to the power of 1 to get you 3/2. And then from here, you can apply the power rule. We keep the 4 outside. We take 1/2, we add 1, and then divide by that. We keep the -3 outside. We add 1 to 3/2, divide by that. 1 and 1/2, 3/2. This is 3/2. Together, 5/2, and then 5/2. Okay. So now we know that dividing by 3/2 is multiplying by flipping that, become 2/3. The same thing here, 5/2 down here. When you bring it to the top, you are flipping the 5/2 into 2/5. And then all you do now is you find the expression, the value of the expression from 4 to 9. Okay, because that is the value of the integral. Okay, so we plug in the endpoint. I take 9. I plug into anywhere I see r. So that 9 go to here, minus, this become 9. So that is the first endpoint. And then subtract using the fundamental theorem of calculus. Right, subtract, plug in 4, go to all the r, 4. And then you can simplify everything. 9 to the power of 3/2, that gives you 27. Right. Remember here, let me do one more step here so you can know. 9 to the power of 3/2. This is the same thing as 9 1/2 and then to the power of 3, because 3 times 1 is 3/2 here. We know that 1/2 is the square root, right? So 9 square root of 9 become 3, and then we still have a 3 outside. This becomes 3 times 3 times 3, 27. And that is how I got 27 here, from 9 to 3/2. And then similar things happen to all the exponent here, and you can find that all the value you get here. And then you can just use the calculator to help you to get to this fraction. Subtract, and then subtract these two, you get that. And then minus become plus, and add them together, you get this fraction. This could be done easily by the calculator, the graphing one, or just the scientific one. And that is the end of question 4. This question, they ask you to find a supply function. Given this equation, and that the supply and demand, they are in equilibrium as the quantity of 9, and find the producer surplus. Oh, sorry, they give you the supply function here, right? And we know that the supply and demand, they are in equilibrium at the location of quantity of 9, and now they ask you to find the producer surplus. So from chapter 7, we know that the producer surplus has this formula. So the producer surplus is the integral from 0 to Q0 P naught minus S of Q and then dq. Okay, we know that in this case we are given that the supply and demand, they are in equilibrium as the Q equal 9. This is Q naught. This is your Q naught. So your Q naught become 9. Now, how do I find P naught when I have Q naught? Well, we got the equation for the price, right? The price here. 100 plus 3Q to the power of 3 half plus Q to the power of 5 over 2. When we know that Q is equal to 9, you plug in 9 here, and then make the summation of these three values. You should end up with 424, and that is your P naught. Okay, so we got P naught 424 minus S of Q, which is this expression right here, and then all together dq. Okay, you can subtract 424 to 100. That gives me 324, and then make the distribution. Minus to the plus become minus, minus to the plus become minus, and then from here we can apply the power rule. 324, when you take the integral, attach the Q in this, you add 1 divided by that, add 1 divided by that, and then we evaluate the answer from 0 up to 9 due to the limits here. We can further simplify before we plug in the endpoint. So you can see that this is 5 half and that is 7 half. Okay, and now you can move this one up. So 5 over 2, when you bring it up here, you are flipping, become 2 over 5, and then 2 times 3 becomes 6 over 5. Same thing here, 7 over 2 becomes 2 over 7 when you bring it up. And now it's time for you to plug in the endpoint. 9 go to all the Q's. 9, 9, 9 here. That is the first endpoint, the upper limit. Subtract, plug in 0 to all the Q. And we know that 0 times anything is 0, so the whole thing on the right side is 0. And all you have to do is you use the calculator to help you to get these fractions, these values, and subtract them together. You get that amount of money. So the producer surplus is 1,099, 54 cents. Okay, question 6. Find the integral. This one doesn't have the limit, so we know that this is the indefinite integral. Well, this question has the product between an exponential expression and another polynomial. So it's the best integral to use the technique that we learned from section 7.8.1, the iteration by parts, or the tabular methods. In this case, I choose to use the tabular methods because I know that when I split this one into two terms, I know that when I take the derivative of 6x plus 3 the first time, I get 6, right? 6x becomes 6, 3 becomes 0. When I take another derivative here, I get 0 because this is the constant. Because I can take the derivative down to 0, I know that I can apply the tabular methods. Now, this expression, e to the minus 2x, the left side I take the derivative, the right hand side I take the integral. The integral of that become e to the minus 2x divided by k. Your k is minus 2. Remember the rule for this? Equal e to the kx divided by k. Your k is minus 2. Take it one more time, divide by another minus 2. Minus 2 and minus 2 become 4. And then I use the plus, minus, plus, and then draw the diagonal lines and so that you can multiply these two together. So 6x plus 3 multiply with this minus 6 times that, and then add c at the end. And then you can see that I can bring the 2 here and make sure the minus I carry all the way outside. Divide both by 2. I got 3/2. And then I can, from here, I can make the distribution of minus 6x over 2, 2e to the minus 2x, and minus 3 over 2, 2e to the minus 2x, and then keep that the same and add c. We see that we can also combine these two. Minus 3/2 become minus 3e to the minus 2x. Because this is a constant, we can combine the like terms. 6 divided by 2 give me minus 3x. So that is the final answer. Okay, so make sure that you make the minus go to 6x, minus go to 3. That's why I have minus 6x over 2 with that, and minus 3/2 with e to the minus 2x. Okay, this the next problem. Okay, we know that our stocks, we have a plot for the stocks with the price per share as the function of time. That can be approximated by the function s of t. T is the time in years. Now they ask you to find the average price of the stock over the first 6 years. So this is the average value problem, which is we are using the average value formulas from section 8.2. And for the average value formula, we know that we take the integral from a to b. 1 divided by b minus a, and then take the value of the function. In this case, we are looking for the first 6 years. So we know that we go from 0 to 6. 0 is a, 6 is b, so we have 6 minus 0. And then we take the s of t, which is this function. And we can evaluate this integral easy. This is 1 over 6. 37, when you take the integral, that becomes 37t. 6, I keep it outside. I keep e to the that power. Divide by k. K is minus 0.03. That's the rule. And then we evaluate the answer from 0 to 6. And I can simplify this one before I take the subtracting the endpoint. So here, I take 6. I plug in all the places. I see t, 6 and 6. Subtract 0, go to all the t. 0, 0. And then just make the calculations from your graphing or scientific calculators. You should end up with that. Times 0 is 0. Anything to the power of 0 is 1. That's why I have 200 here. And then make all the calculations here. You should get the average price to be $42.49. Okay, the last, the next to the last example. We are given the rate of a continuous flow of money stacks at $1,000 and increases exponentially. This is the keyword, exponentially, as 5% per year for 4 years. You are asked to find the present value and the accumulated amount of if the interest earned is 3.5%. Compounded continuously. Okay. First thing is we need to find the function of the flow of money. We know that the flow of money starts as 10,000 and increases exponentially. So we have to use the exponential model from chapter 1. f of t equals c e to the kt. C is the initial amount of money, which is 1,000. The rate is k. We know that the rate is 5% per year, exponentially for 5% per year, which is 0.05 for k t. So f of t here is the flow of money. And now you are finding the accumulated amount of money, which we can apply the formula from section 8.3. Right, this is the formula from section 8.3. We know that the big T here is 4 because we are looking for 4 years. Okay, so now I have everything. I have e to the r. We know that the interest earns for 4 years 3.5% compounded continuously. So r is 3.5%, which is 0.035. So I plug in r for 0.035. T is 4, 0 to 4, and then f of t, we just found it here. So I wrap it and bring it down here. And then e to the minus 0.035 for r, and then t, and then dt. Now I can multiply these two, I get that value. The same base e, I can add exponents together. I get 0.015t. And then from here, before I take the integral, I see that 1,000, I can bring it outside because this is a constant. And then I can take the integral of e to the something. The integral of e to the sum kt is e to the kt divided by k. K is 0.015. And we evaluate the answer from 0 to 4. 0 to 4. So I keep whatever outside here. I plug in 4 for t. Subtract, I plug in 0 for t. And then I got the answer. 4,741.93 cents. So that is the accumulated amount of money when the interest earned is 3.5%. Compounded continuously. We also need to find the present value. Okay, so again from section 8.3, we know that this formula is the formula for the present value. And if you compare with the formula you saw earlier from here, right, this is the accumulated amount and this is the present value. They are very the same, except that in this formula we have this extra term e to the rt. This term right here is the present value. We don't have this extra term, right? So to find the present value is simple. We already got the value for this integral. Because we don't want to include this term, so to get the present value, all I do now is I divide the final value to this extra term so that I can get whatever I have here. Okay, so the extra term is e to the rt, which is e to the 0.14. So I take whatever I got earlier, I divide by that factor, and I get this term right here, which is the present value. Okay? Alright, the last question. We know that the flow of money, $500 per year, assumes a 10 years period of 8% compounded continuously. So find the following: the present value. Okay, so we know that we have the rate 8%, 0.08. in 10 years, so the big T is 10. And to find the present value, we apply this formula from section 8.3. T, the big T is 10, f of T is 500, e to the minus r 0.08 T. And I can bring the 500 outside. The integral of e to the anything is e to the minus 0.08 T divided by k. K is 0.08. And then evaluate the answer from 0 to 10. And plug in 10 to T minus plug in 0 to T. And then just find the answer. So that is the present value. To find the accumulated amount of money flow at the 10 years, again, this is the present value. All we need is we need to multiply by this extra term, e to the r big T, to get you the accumulated amount. We already got this value with this number. So all I do now is I multiply with this extra factor right here. So we got the answer. Take that, multiply by this extra, and then get the final answer, which is the accumulated amount of money flows at the T equal 10 years. Okay, so that's the end of the final exam practice questions. Thanks for watching.